Okay, hi, we're going to talk about solving a system by substitution. In my earlier videos I was talking about how one of these problems was already set up with one of the variables being defined for and setting it equal to. In this one I'm going to show you here is that both of these equations of the lines are written in standard form already. So the problem with that is that one of my variables isn't defined. So what I need to do is I need to change one of my equations into y equals mx plus b. Now I don't have to do it for both, I only need to do it for one, and then I can use the substitution for that method if I want to. I could also change it into writing x as a function of y. So the things you want to look for is, one, do any of my coefficients of my variables have a 1? And if that's the case, that is always the best one to solve for. So in this original problem, the 3 is the coefficient of x, the 1 is the coefficient of y, and in this problem 2 is the coefficient of y and 5 is the coefficient of x. So the thing that I want to take note here is that I have to solve for one of these variables in one of these equations. And up here in the first one, like I said, you want to kind of look for which one has a coefficient of 1 or which one's going to make your life a little bit easier. And that's the only time that I would really use substitution, is if I had something with a coefficient of 1. So this one has a coefficient of 1. So what I'm going to do is I'm going to solve for y because y has the coefficient of 1. So this problem here, I'm going to write it up as 3x plus y equals 4. And what I'm going to do here is just solve for y. So minus 3x, that goes away. So minus 3x. So what I'm left with here is y is now equivalent to negative 3x plus 4. So why is that significant? Well, that's now significant because still I haven't changed any of the variables over here. This y over here, okay, what I want to take note of is that this y here is still the same exact y as this one. So since those are still the same, I can now begin to say, well, if this y is negative 3x plus 4, well then this y over here must be negative 3x plus 4. It must be the same exact function. So what I can do now is that instead of writing 2y, I can write this as negative 3x plus 4. So I'm going to write y in terms of its function. So wherever I see a y down here, I'm going to replace it with what I said its function is. So this becomes 2 times negative 3x plus 4. So this plus 5x equals 12. And then I go through the same process that I did last time. I start to solve for, in this case, it's x. So I get negative 6x plus 8 plus 5x equals 12. So from here I can say that negative 6 and positive 5, they're on the same side, so I just combine them. So this becomes negative 1x plus 8 equals 12. And negative 1x, you don't have to write the 1. I just did because some people like to see it. So this becomes, and down below I won't write it, so I minus 8, so those go away, minus 8. So 12 minus 8 is 4. And what I'm left here with is negative x equals 4. So now remember that you should always solve for the positive variable. So in this case I would divide by negative 1 and I would be left with x being equal to 4. So now that I have x equals 4, what I can do is that I know that x equals 4 and I know my answer must be a coordinate pair, so I can come back up to this equation which says y equals. So I come up here and I say y now equals negative 3 times, so in this case negative 4, negative 4 plus 4. So negative 3 times negative 4 is positive 12. 12 plus 4, I get y equals 16. So remember that I must write my answer as a coordinate pair because I'm still looking for the point at which these two lines cross each other. So the coordinate pair here is negative 4, 16. Well, this is my x, this is my y. So I hope that helps with any homework problems that you have to do.